We're going to talk about scientific notation. For starters, we often see two different types of notation. Standard notation, which is just a regular number the way we're used to seeing it most of the time, and scientific notation. Scientific notation is used to write numbers that are either very, very big, like this number, or very, very small. It's a way of simplifying long numbers so that we don't have to waste our time writing out all these digits. In standard notation, this number is 1,240,000,000. In scientific notation, this is 1.24 times 10 to the 9th power. Remember that a small number in the upper right corner of a larger number is called an exponent, or power. The number 0.000000084, which I'm not even going to try to say, in scientific notation is 8.4 times 10 to the negative 8th power. So I'll explain how we got here, but what I want you to notice is that scientific notation involves writing some number as a decimal times 10 to some power, and that power can be either positive, as it is here, or negative. The other thing I want you to notice is that these numbers are equal to each other. So standard notation and scientific notation are just different ways of writing the exact same number. We've changed the way the number is written, but we have not changed the value. So here we have 1,240,000,000, and we're going to take this large number and write it in scientific notation. The first thing we need to do is look at the first non-zero digit. We have 1, and then we get a 2 and a 4. We're going to write this as 1.24 when we are writing out the answer in scientific notation. 1.24. So with scientific notation, you always take the very first digit, put a decimal after it, and then write all the other non-zero digits that follow. Then you're going to multiply that number by 10. So we have 1.24 times 10 to some power. Now we just need to figure out what this power is, what this exponent is. So in order to do that, go back to your original number and find where the decimal is in the number. Obviously, we don't see one, and here it's because it's a whole number. But we know that every whole number has a decimal at the very end, so we're going to go ahead and draw that decimal. Then, before we even pick up our pencil, we are going to start moving the decimal over however many spaces we need to get between the 1 and the 2. While we're doing this, we're going to count. 6, 7, 8, 9. I have moved 9 spaces over to the left. So I will have 9 as my exponent, and because I moved left, my exponent will be positive. It will remain positive. Again, I always have to have my decimal right after the very first non-zero digit, so when I'm counting my spaces, I stop right after the first non-zero digit, between the 1 and the 2. So we got 1.24 times 10 to the 9th power, and the 9 is positive because when we were moving our spaces over, moving over digits, we had to move to the left. So direction matters. If you move left, your exponent is positive. Another way to look at this is to remember that the exponent will be positive for whole numbers. So we said that we use scientific notation for either very, very large numbers or very, very small decimals. So for the larger numbers, you're going to have a positive exponent. Next, I'll show you that for small numbers, for those tiny decimals, you're going to have a negative exponent. So we're going to write this small decimal in scientific notation. The first thing we need to recognize is that we write the very first non-zero digit, which is an 8, put a decimal behind it, and then follow with all the other non-zero digits, so 4. We're going to have 8.4 times 10 to some power, and the next thing we need to do is figure out what that power is. So we look at our original number and we find the decimal right here in blue. Then we're going to move our decimal over and count the spaces until we get between the 8 and the 4, where our new decimal is going to be. 3, 4, 5, 6, 7, 8, and stop right there. So I'm going to have an exponent of 8. However, unlike in the previous problem, what we did here is we moved right. So our exponent is going to be a negative 8. So we end up getting 8.4 times 10 to the negative 8th power. Remember, the exponent is negative, not the whole number. So this is still a positive number. It just has a negative exponent. And all that means is that we're ultimately going to end up with a decimal answer. So whenever you have these decimals and you have to move over to the right, and I point my arrow to the right to show which direction I moved, that's when you get a negative exponent.